Greetings, Math 10 students. This is the second part of our video on compound interest, section 3.8. If you haven't checked out the first video, part 1 of compound interest, please make sure that you watch that one before watching this one. In this video, I'm going to assume you already know how to use the compound interest formula and know what compound interest is. We're just going to focus on different compounding periods in this video. So we're going to take a look at what happens when you see compound interest, but it doesn't say compounded annually. It'll say compounded semi-annually, quarterly, monthly, or daily in some cases. So if you're not sure how to do compound interest at all, please go check out that first video. So to start with, a compounding period is the number of times per year that your interest gets added back to the principal. That's called compounding. When the question says that your interest is compounded annually, that means it's just getting compounded once per year, and we kind of don't have to worry about it too much. That's just the typical baseline normal way of compounding. But there's different ways that you can compound. You can compound things multiple times a year, and that's what we're going to look at. So annually, if the problem says that the interest is compounded annually, that's just one time a year. Ignore it. You're not going to have to worry too much about that. We're going to use the formula as usual as we did in part 1. So if your problem says compounded annually, go check out the first video. That's going to show you how to do those problems. Now there are other compound periods though. Semi-annually is something that happens twice a year, 2 times per year. So if your interest is getting compounded semi-annually, that means that you're getting a little bit of interest after the first 6 months and then getting the rest of it after the next 6 months. You're getting it twice a year. Well, you can't get all of your interest after the first half a year. It wouldn't make sense. You'd be getting too much interest. So they actually take your interest rate and give you half of that rate after the first compounding period and the other half after the second one. So it effectively divides your rate in half, but since you're getting compounded twice as often, it's going to multiply your time by 2. And this is going to happen before you take your numbers and put them into the formula. When you see semi-annual compounding, when you're listing out your principal, rate, and time, that second step where you're doing your conversions, you're going to take the rate and divide it by 2, and take the time and multiply it by 2. And something similar is going to happen for all the other types of compounding. Quarterly compounding, for instance, is 4 times a year. So if something happens 4 times a year, well, that means you would divide the rate by 4 and multiply the time by 4. Quarterly compounding, that's what you'll always do. Monthly compounding, well, monthly is 12 times per year since there's 12 months in a year, and that means you're going to take your rate and divide it by 12 and take your time and multiply it by 12. The only weird one here is daily. Of course, there's 365 days in a year, or 366 in a leap year, but banks are kind of weird, and a holdover from the past when it was harder to do computations, they like to treat it as though there's only 360 days in a year. Now this isn't all banks by any means, but there are some that do this, and the Hawks homework assignment and our textbook, and even the Math 101 textbook will do this as well, will tell you to assume that the banks are using 360 days per year. So instead of 365 for daily compounding, you're going to use 360. But those are the 4 different compounding periods that you want to watch out for. Again, if it says annually, don't worry about any of this. You can safely ignore the compounding period. If it says semi-annual, quarter, monthly, or daily, you're going to do these adjustments in step 2 when you're doing your conversions. Just as a side note, this is again the way that the Math 101 textbook does things, not the way the Math 10 textbook does things, although these compounding periods are typically the same. Our textbook uses the letter N to represent compounding periods, and that's pretty standard. I'm not really going to do that too much. I'm not going to worry about the way that it gets put into the formula the way our textbook does it, but if you want to do it that way, feel free. These are still the same numbers that you would use for those compound periods. All right, let's take a look at an example, and you'll see that it doesn't really make it any more difficult. It's just one extra step you have to do. So we have Barbara, who's investing $4,800 into an account that is compounded quarterly at 1.2% for 5 years. And we want to know how much she's going to have in the account at the end of the term. Great. Well, we'll go with our normal step 1, which is to list our principal, rate, and time. The principal is the original amount of money invested or borrowed, and that's $4,800. The rate is that 1.2%. In the second step, you would normally convert that to a decimal. I already did that here because we're going to have some more conversions to do in a moment. But 1.2%, I just move the decimal place twice, or divide by 100, and I get 0.012. And then the time is 5 years. and since it's in years I don't have to convert it to years. Now the compounding period is quarterly, compounded quarterly. So in my convert step, quarterly means 4 times per year, so I take my rate and I divide it by 4. 0.012 divided by 4, that's 12 thousandths, divided by 4 becomes 3 thousandths. You can punch that in a calculator, but if you understand how decimal numbers work, you could probably figure out that 12 thousandths divided by 4 is 3 thousandths without a calculator. Punch it in the machine anyway, just to make sure. And then 5 times 4 you can hopefully do without a calculator, right? So that will give you 20. Excellent. So you're just taking the rate and dividing it by 4, taking the time and multiplying it by 4, and it's because we're compounding quarterly. If this had said monthly, I'd be using 12 instead of 4. If it had said semi-annually, I'd be using 2 instead of 4. And then daily, I'd be using 360. An important point here is I don't want to round any of the numbers yet. That 0.003, I'm going to leave it as is. Do not round it. If it's a really ugly long decimal, same thing. Just leave it. And then the last step is to put things into the formula. Same formula as last time. Amount equals principal times 1 plus the rate in parentheses to the exponent of time. The formula in the book is a little bit more complicated, but we got around some of the complicated bits in the formula by doing this conversion step right here up front before putting things into the formula, which I think is a little bit easier. It's the way the Math 101 textbook does things. So let's go ahead and put our principal, rate, and time into the formula. And just as a reminder, we're using these numbers. The principal is 4,800. The rate is this new converted 0.003, and the time is this 20 right here that we converted. So a lot of these numbers didn't appear anywhere in the original problem, which is why I say you really want to do this conversion as a separate step, and write that out in your homework post as well. Even when you're doing the Hawks assignments and you don't have to technically show your work, write this out on paper so that you don't make any mistakes with it. So let's go ahead and put those into the formula. P gets replaced with 4,800. 1 comes straight down. R gets replaced with the 0.03, and my exponent T gets replaced with an exponent of 20. Next up in order of operations says do your parentheses. I typically will just do this without a calculator and almost even skip that step. I'm just replacing the 0 here with the 1. 1 plus 0 is 1, and then I bring the decimal part down. So that's 4,800 times 1.003 in parentheses to the 20th power. Now, some calculators you can punch this in as is and it will give you the correct answer, but be careful. Not all calculators handle order of operations properly. So check your calculator to make sure it's doing things the right way. I would do the exponent first, 1.003 to the 20th power, get this long, ugly decimal, and then at the end multiply it by the 4,800 because multiplication comes at the very end, and it'll give you $5,096.35, and then after the 5 comes something bigger than 5, so it rounds up to 36. And that would be my final amount. So to summarize, with compound interest, if you are given a compounding period, anything other than annually compounded, you have to make some adjustments in step 2. If it says semi-annual, you're dividing the rate by 2, multiplying the time by 2. Quarterly, you're doing it by 4. Monthly by 12, and daily by 360. You're always dividing the rate and multiplying the time, and you're doing it in step 2 before you put the numbers in the formula. Once you're moving on to the step with the formula, it's exactly like how we did it in the first video.